So I recently started doing binary search and I encountered this problem. Find minimum in a rotated sorted array. And I went through the Striver solution, which worked. I went through Neat Code solution, which obviously worked. They were pretty good, but I couldn't digest one thing, that they were checking the last element, like the next and the previous element. If the middle is lesser than both of them, then it is the minimum. But I don't think we need that extra step for this. Even with the neat codes approach, like finding the minimum by comparing every mid, I don't think that is very necessary. I will show you why and what I thought of personally when I encountered this problem. So let's take this array 3 4 5 1 2. Okay, so we have this array 3 4 5 1 2. So let's see. So let this be my start, this be my end. One second, sorry. This be my end, and this be my middle element. Let's just assign this L, M, and R. Okay. So if you think logically, the if the middle element is greater than the right element, then the array is obviously rotated, because when we are rotating in an in the ascending order, the bigger element will always come at the start. We know that concept, right? So in that case, the minimum element will always be the right of middle, because middle is greater than the rightmost element. So we can put the condition L equals to m plus 1. Okay. And then suppose we have an array. Let me think of an example. Let's just say we have an array 7 4 1 2 3, or let's say, okay, so let's take an array. We will just rotate this array a little bit less to give you the idea of what I'm trying to do. Let's say that the array is 5 1 2 3 4. This is also a rotated array, correct? Allot these a bit of space to make it clear, otherwise the arrows will mess up. Okay, so let's just say this is also a rotated array. This is the same array, but it is rotated only by one index. So let's take this example. We have an array. This is the same array as above. I just, instead of rotating it by three indices, I rotate by one index. So in this case, my middle is less than or equal to R. So the right part of this array is sorted. And definitely if the right part is sorted, then the lowest element will definitely be the middle. So I can say that currently, what I can say from this information is that the lowest element will either be the middle or be on the left of the middle, because since this part is sorted, since this whole part is sorted, the lowest element can only be the middle, because this is sorted in an ascending order. So it will definitely on the left of the middle, or it can also be the middle. I will show you the case in which it can be the middle as well. Take this for example. I will give you example with the same array to clear your understanding. So let's just take the array 4 5 1 2 3. So in this case, what is the middle? 1, right? So if my middle pointer is at 1, again 1 is the smallest element in the rightmost sorted array. So I can't do r equals to mid minus 1, then it will go to 5. And as we can see that 5 is not the smallest element. Logically, if you think, it is very clear that 5 is not the smallest element, 1 is. So we have to include the middle element when we search towards the left. So this is all it takes. Either it be only either it be an array with only one element or 10,000 elements. This will work. I will show you the execution and the code. Okay, so this is the code. Simple binary search. We initialize the left and the right pointer. Mid we take as L plus R minus L by 2. Why? Because if we do L plus R by 2, then the problem is, what if there is an integer overflow? What if both of them, if I add both of them, it exceeds the max integer value, that is 2 to the power 31 minus 1. So we use this. Aditya Verma has a very good video on this. You can also check him out. So let's start. So while simple binary search, while left is less than equal to R, why I have again initiated? Actually, there could be a better approach to this, but I have to return the middle element outside the while loop, and I can't do that unless it's a global variable. So I initiated it like this. I could have also done 0, but let's just keep it at this. You can test if it works with 0. So again, the logic is nums mid less than equals to R, L equals to mid plus 1. Why? Because if mid is greater than equal to R, then since the array is rotated, the minimum element will definitely be to the left of the middle. You can also think of it is as that this way. Since middle is greater than equal to R, then this part is sorted 3, 4, 5. So the bigger elements got rotated and put at the start of the array. So definitely then the minimum element will be to the right of the middle in this case. And if nums mid is less than nums R, that means the rightmost part of the array sorted. Then the minimum element can be both in the middle and towards the left of the middle. We have to consider both possibilities. And so if I just run this, okay, so it ran. All the public cases are clear. Let's just submit and see the answer. Okay, it varies from 0 to 3. This is none of your concern. You can check the runtime. It is still log n. If I analyze the time complexity, it is log n. So it is definitely binary search. So here you have it. A simpler solution I thought of, because I couldn't digest the solutions provided or available online.